Hello everyone. Today we see about how to implement 4:1 demultiplexer using VHDL. Okay. So this- before we going to design, we want to know the basics of 4:1:4 demux. Okay. So this is the block diagram. So we will have only one input, and for that we have to select lines. We want to select lines in 4 outputs. Okay. So we will select the select element 2 power the 2 power n equal to output. So 2 power 2 is the 4. So using 2 input S0 and S1 and output. Okay. After that, this is the circuit diagram and this is the truth table. So input and select line is 0 0 means then output D0 will be 1. If select line 0 1 is, then the output D1 will be 1. If selected lines 1 0 is, then the output D2 will be 1. If select lines 1 0 1 1 means then the output D3 is 1. Like that you will select the input and demand. This and all used for the telecommunications applications. Okay, so now we going for the Chinese platform. Here we using ISC 14.7. Okay, for if you want to create project, just click file, new project, give 124 demux, click next. Here this is the project settings. So here we want to select the FPGA family and the speed and preferred language. I am using VHDL, so I am selecting the VHDL language. Click next, finish. Here just after completion of the file creation, we want to go for the source file. So just click source file and click VHDL module and give file name demux. Okay, click next. Here we want to select the input and output. If you see, block diagram means 1 input, 2 select lines and 4 output. So just give I is the input and x0 x1 is the select line, so in and out, and D0 D1 D2 D3 is the output. Okay, just click next and finish. After developed input, in and output, we want to give the expression in the begin. Okay, after the begin. So if you check, this is the circuit. So Y0 is the D NAND, not S0 and not S1. Okay, so D0 will be the input I and not S0 and not S1. Okay, so D1 will be, so there is two way of developing the demultiplexer or multiplexer. So one is by using the if statement. If output is select line is 0 0 means, then like that using the if and else statement we will develop. Other one by using logic gate. Here I am going for the logic gates. We can also develop by using the if and else statement. Okay, so next for Y1 D, okay, I and not x0 and x1, D2 I x0 and x0 and not x1. Okay, so d3 will be I and x0 and x1. This is the logical expression of the 1:4 DMAX. Just save and we'll check whether there is any error or not. For that we want to click the check syntax. After check syntax is run, we want to check the RTL schematic and technology schematic. There is no any error, so just check the RTL schematic. So if you see me, there is only one input, 4 output, and bidirectional is S0, S1. So this is the circuit diagram, and we want to check the LUTs. So we are using 1, 2, 3, 4 LUTs. If you click the LUTs means you can able to see schematic equation, truth table, and K-map of the each LUTs. After checking the RTL schematic and the technology schematic, we want to check the design summary. So whatever we going to design, we want to check the area, power, and delay. For that, just click synthesis report. Here you can able to know how much LUTs we are using, how much input output we are using. So we are using 7 input and output, and we are using 4 LUTs. Okay, after that we are using 7.8598 nanosecond. Okay, level of logic is 3, and we want to check the static power analyzer. For that we want to run the analyze power distribution that will be in place and root section. So for that just run analyze power distribution. For that translate, map, and place and root. Implement. This is for the implementing the design. What we design we want to implement that one, right? So for that translate and map and place and root will be create. So after translate, map, and place and route process is over, Xilinx power distribution will be run and Xilinx power analyzer window will be open. So here we can able to see the static power analysis. Okay, so 0.060 is the total power watt for 7.785 nanosecond. Next we want to check we want to next see the simulate behavior model. For this just click simulate behavioral model. So here we give input value 1. Okay, so now here we select the force constant 0, we also another type to give input and time delay that is called test bench. For analysis purpose, for learning purpose, I am giving separately for F0 and S1. For developing any project or developing your project means go for test bench. just click and run. So 1 will be selected. After that 0 1, D1 will be selected. After that 1 0 0 and x0 is d1, D2 will be selected. Okay, next both will be 1, D3 will be selected. So how we will get expression circuit diagram is by using K-map. We know truth table. From the truth table we will go for the K-map. After selecting the and after emitting some after selecting and after getting the K-map, from that K-map we will get the expression. So from that expression we can able to develop the code. Okay, so we know truth table for the Dmax. From that truth table we will go for the K-map. From that K-map we will get the expression. From that expression we will develop the code. Okay, and also we will develop the Dmax. So what we develop is right. Okay, x0 selected lines is 1 1, input is 1, and also D3 is selected. So if you check truth table means, then we can know 1 1, then D3 is selected. Okay, so we designed 1:4 Dmax and we analyzed the power, area and delay also, and also we check the RTL schematic and technology schematic also, and also we check with truth table with the simulation window, simulation output. Okay, thank you.